Good evening and welcome to this evening's webinar, the Exam Readiness, Mathematical Applications and Methods, hosted by Texas Instruments Australia. My name is Rodney Anderson and I'll be your host for this evening's webinar. So you'll see with the panellists tonight we have John, a very experienced presenter. Hello John, we've chatted
Good
before.
evening Rodney, nice to hear from you.
Yeah, it's good, thank you for that. And then Carol, and Carol's another very experienced presenter, as you've seen in the introductory slides as you're waiting for the webinar to commence. Hello Carol.
Hello everyone, hi there.
And Carol will commence with tonight's part of the webinar, so it's all over to you now, Carol.
Thank you. Thank you for the opportunity, Daisy. So, SACE Exam Readiness Maths Methods and Maths Applications, these are largely or exactly South Australian but are also done in Northern Territory, so we'll be using our South Australian exams for that. A couple of really important things in terms of exam readiness. You need to be aware of what is available on the SACE website. Each year, as you will know, there's a copy of the exam paper from the previous year plus the Chief Assessor's comments, and the report indicates what's been done well, what's been done poorly and so on. And in particular, there's usually comment about use or otherwise of technology, which we're interested in tonight. Also note that 2016 is the last year of the current 5 mathematics subjects, and new syllabuses and new names are now available for only 4 maths subjects instead of the 5. On a local note, the Maths Association of South Australia is in the process of writing new revision guides for essential mathematics, general maths, maths methods, which was formerly maths studies, and specialist maths, and these will be available next year. But please don't rely on our interpretation of the syllabus statements. You must ensure that you're aware of the quite significant content changes and movement of content across the subjects. So moving on, the most pertinent comments in the 2015 Chief Assessor's reports are these. Discerning use of electronic technology in the examination is encouraged. Students may use their graphics calculator whenever they see an opportunity to do so, and that is usually indicated by the number of marks allocated in a question, but sometimes it's a good idea to use the calculator regardless, just to see whether an answer is correct. And this is an interesting one. There's no need to indicate to the examiners when you've used your calculator. Evidence seen in the examinations indicates that some students are reluctant users of their graphics calculators. I shouldn't say this on air, but that's probably the Casio users. I'm sure the TI people are very good at it. It was evident that many students do not know how to solve simultaneous equations using their calculators. That's something John will tackle a bit later on. Excuse me. However, the vast majority of students were able to accurately enter data into their calculator, well, at least that's something. And while it's probably a little late to learn new calculator tricks for this year's cohort, many of the calculator tips we'll use tonight and in tomorrow night's webinar on specialists and studies will still be useful tools for future years. So starting out with business mathematics, there are various comments through the Chief Assessor's report that are worth looking at. And in the statistics section, there was a comment about the sketching of a second normal distribution on the same scale not being well done, and understanding that the size of the standard deviation and so on actually changed the way the graph looked. So very quickly, I've got a normal PDF for the variable x with a mean of 15 and a standard deviation 50 and a standard deviation of 15, and I've pressed graph. Now, one of the reason I've done that is so that we can have a bit of a think about what students should know to be able to draw a normal distribution, and I think that's really important. If I look at the window for the scales, this was a 50 mean and a 15 standard deviation, yes. So on the window, I need to go plus or minus 3 standard deviations from that mean. So if I go back to 0 there and through to around about 100, I ought to be able to get a graph. And because x is going from 0 to 100, I would make the x scale 10, so there aren't a lot of marks there. Clearly the y minimum would be 0, But the issue is, what would the Y maximum be? Now, the simplest way to work that out is to look at your table of values, but another way to do it, just to show that one, is to actually have a look at the function Y1, evaluate it at the mean, which is 50, and have a look what that is. Well, that's 0.026, so if I make my window Y values go up to about 0.06, I'll get a reasonable graph. And so graph, and we'll have a bit of a look at it. So that's the first normal distribution, and I think the issue of mean plus or minus 3 or 4 standard deviations for your x-axis is a good one to bear in mind. I'm going to put another graph on there now, so to show you how to do that, it's second distribution, normal PDF, enter, x is the variable, 50 is the mean, and I'm going to change this to 10, that's right, I've already had that in there, and come down to paste, and I've pasted it in the wrong spot, which is fairly dopey. So delete that one. So delete, mess. Okay, I didn't go down into the second place. So second distribution, normal PDF. I've got everything I need there, 50 and 10, and paste it in and graph this one. Oh dear, oh dear. Rodney, you've put the lurgies on us tonight, mate.
Quite possibly have.
Probably have. I'm going to change this one to, I can do it here anyway, change this one to 15 and draw it. So now we have a second graph with a different standard deviation. One is smaller than the other, and so clearly the two graphs are going to look different. They have the same mean but different standard deviations. And of course the reason for that is related to the fact that the area under the curve is about 1 in each case, or it's exactly 1 in each case if you go from -4 standard deviations to +4. And so even though integration is not part of the course, it doesn't hurt to show that illustration with the area under the curve. But I won't do that at the moment. The other thing that I'll do a couple of times in my presentation is use a graphical database, or sometimes the syntax can already be stored at Y8, Y9 or Y10 if you want in your Y equals line. And the idea is carried through in question 3 of the stats as well. This time the managers are perfect chocolates, blah, blah, blah. You can read that. There are two options. They have two options to improve the situation, option A and option B. And option A is already drawn, and the students were asked to draw the second option over the top of this one. Now, if they know how to draw a graph of a normal distribution, which is the Y equals button, they really ought to be able to do this one quite easily. So I'm just going to move across and change that to 208, comma, and 3 as the standard deviation, and in the next one, leaving the mean this time as 205, comma, standard deviation of 2, we know that the first graph, graph A, is already drawn, and this time the students have to be able to draw the second one over the top of it. Oh dear, and I haven't got the window sorted out for this one.
The window, Carol, that's all.
The window. So if I look, this is another thing that students often forget. If I actually look at this scale on the graph in the question, it appears that I wanted to go from about 195 for the minimum X to about 220. I'll put 225 there. And again, I have no idea what this value will be, so I'm going to put about 0.2 there, something like that. Clear that one, 0.2, and let's just see if we get a picture. Okay, there we go. And so the first one, option A, was given. The second one now is clearly there, and it has a different height because it's got a smaller standard deviation. So to get a total area of 100% under the curve, it's narrower and therefore it needs to be higher. And many students apparently didn't understand that. Now, John, I can see we're going to run out of time very shortly, so I'll just flick through the next thing I was going to do. Question 2 was about... Well, I don't want to cut your time.
We started a bit late, Carol, so it's
all
fine.
Right, okay. Well, in that case, I'll keep going then. The next question, question 2 out of the stats section, asks students to deal with some data related to some marks in an examination. And so I've already put these in the edit list. And the students are actually asked, they actually have to be able to get the one variable stats to put them into a table that's given in the question. They also have to be able to draw a box and whisker plot of that. And so it seems to me that a good idea might be to actually draw the box and whisker plot first. But the other thing is that because students apparently didn't do very well at drawing a stem and leaf plot, I wondered whether people understand that the best thing to do is really, if I just put this list in there again, the best thing to do is reorder list 2. And so if I do that, sort in descending order, list 2, I'll put it in 2, so I'll just keep doing it in list 2 and then have another look at it. Descending, of course, can be descending or ascending, it doesn't really make much difference. So list 1, I think one of the problems for students is they forget to actually order the list, so it's actually easy to do a box and whisk, a stem and leaf plot when they're in some sort of order, which just seemed to make sense to me. And then we can actually also have a look at the this plot. Now, one of the questions here for students is whether you use a box and whiskers plot, the fourth one across that shows outliers, or whether you use one with outliers. And I don't think there's any actual, decision about that. I don't think they actually showed that. And so I'm going to just do one with the outliers so students are aware of it. I'm also going to clear these guys so that that's not going to upset my graph. And then I'm going to press Zoom 9, which will give me a nice statistical plot of the box and whisker. And students should be able to draw those without too much trouble, but of course you can also see the median, the first quartile and the minimum values and so on there before you actually move into doing the one variable stat. So that will of course stat calculate one variable stats for list 1, calculate that, and these will show up. And they will be exactly the same, of course, as you're looking there at what came up on the box and whiskers plot. So I think that's worth knowing about as well.
Nice, Carol.
Moving into methods. So before I do that, we're handing over to John.
Thanks, Carol.
Okay. So Daisy, we'll hand over to you.
And John's clearly screened shortly, is that regarding the windows, very important, isn't it, Carol?
Absolutely. Yeah, and I don't like students just playing around with the up-down buttons and messing around with that. I think they need to think about what values they need on their axes and have a play with that only, rather than just move it up and down the screen as they do on some calculators.
All right. Okay, John, over to you.
Thank you, Rodney, and thanks for that, Carol. So, so my parts will be split into 2. The first one, I'll be looking at using linear programming and using a nice little app on the TI-nspire to make life easier, either in terms of teaching or in terms, and I've used this before with my classes, just explaining it as a class presentation using a similar format to here now, or equally for students to work through questions and to confirm what they do with a pen and paper, and equally to support what they do in the exams as well. So we're going to look at a linear programming question taken from 2015. There was 2 in that year, questions 3 and 7. And we can see that when we go to the apps function, and it's already pre-installed onto the calculator. Number 6 is inequals, which is the inequality. Okay, so it's obviously already working on here. So that's right, I'll just continue with that. And we can see that it now takes me into the graphing screen. Now I'm using the updated version of the TI-84 Plus CE Smart View. That's a free upgrade for teachers who already have the 84 Plus. But equally, I could change the view and work it in the normal different calculator model. I can work in the 84 Plus if I want to, but I'm just going to work in this one because I can, and it's quite nice to have it in the color. So here was the question, question 7, a classic linear programming question for methods in 2015. And I encourage my students to write on the papers. I think I try and give them copies of the papers when they're working through them. You know, with the textbooks, they sort of have this aversion to writing on them, as I do. But if I can give them copies of the past papers to sort of get them to make links when the question's talking about X being the packs for A and B being the packs of B, sorry, Y being the number of packs for B, and linking the two together here, so that wherever they see the X and Y and the A and B together, they can work out which goes with which. I've repeated it here and over here with the B. And then I've also, it would encourage my students to do this as well, where they link the shirts with the shirts, the trousers with the trousers. And I've used colors here, and my students can do that as well. And so can yours, or just use their normal pens. But I encourage them to write on here. That makes their life much easier when they come up with these inequalities. All right, so then in terms of typing those in, we're going to type them into here. And we'll leave out the first one for a second. We'll talk about that in a sec, but I'll type the second one in. So that is going to be 100 minus X. But because it's an inequality, we need to come back over to the right. And if you notice here now, when I press enter on here, we can change, obviously, the color if I want to. I'm going to leave it like that for now, but I need to find the inequality that matches. And equally, if we had to divide by negative, I'd make sure my students are aware of what they needed to do with that, with what happens to that with an inequality. There's the first one done. The second one, yeah, we could use brackets and we could get them to rearrange it, but I quite like using the shortcut keys, F1, and getting a fraction to come up. 200 minus X over 3. And that's where that negative thing would come in. Must make sure that I change the inequality. Now you can see that it does take just a little bit of time for the students to set it up. But once they get into the habit, it doesn't take too long. But like I said, I think I'll leave it with my students to decide whether they do like this sort of system. But definitely encourage them to use it when they're practicing the questions. Just find the other one. There we go. Arrow down. Are those looking okay, Rodney? Have I made any mistakes with those?
They're looking okay so far now.
I have, if I haven't typed 10 in there. Right, now the X one. In the old days of the 84, we weren't able to do much with it. In more recent updates of the 84 Plus, we were able to, and equally we can with the CE. We can go up to the very top where it says X and do exactly the same up here. So I'll change that one to 20. And, oops. Change that one to greater than, oops, no, stick with blue. There we go. And there we are. So we've now got them all set up. So like I said, to get to the X one, I just scrolled up to the very top here. I'll go back to the Y one and convert it to the Y one. Now, before we press graph, and I could turn those back on to just straight normal lines without shading if I wanted to with the equals function. But before I do the graph, like Rodney mentioned earlier, I'm going to change the window to match the window of the question. So 0 to 200, going up by 20. The Y-min is also 0, going up to 120 with a scale of 20 as well. All this is doing the shading. I'm not going to worry about that, and I'm just going to graph it. Now the first graph it will give us is the classic one where it's shading the area that we want. We can see along the top here that it talks about how we got more inequality menus in second calc. So let's go into there, second calc. There's all our normal stuff in calc, but there's also the inequality function here. So I'm going to come across into this. And we can do the union, which is number 3. So is that what we want, or do we want the inequality intersection? No, we want the inequality intersection. So we'll go number 2. And what it will do for me now is it will give us the shaded section. Now obviously students need to draw these graphs onto their, these lines, sorry, onto their, onto the graph in the question. So there's many different ways they can do that. They can still go to table and get some key values off of there if they need to. So that's probably one of the easiest ways. They could also still go into calculate and find values. So if we wanted the values, at say x equals 0, we can still get those values. There's the blue one for x equals 0, it's 100. And there's the red one at 200 over 3. It's come up as a fraction because that's how I set it up on the question, but we can change that to decimal answers if we want to. And there's the horizontal line coming off at y equals 10. So we can get the values from there in many different ways. And what we then would lead on to with this question is obviously wanting to know the vertices. Now, a nice little opportunity for that is to come across into inequality again. Last time we chose inequality intersection. This time we're going to choose points of interest. And it will then give us all the points of interest. And it's nice up here, nice bit of terminology up here, the intersection of y1 and y2. Again, sometimes if I've got my students to write down which ones they are here, I'll link them to which question they linked it to. So this was y1, y2, and y3, if we need to. And we then will then store that value. So that point there we're going to store. So when we press store, that will store those values into the stat list. That's the first one done. I want to get another one to do with y1, which is that one down there. So press store again, enter. Now we want to come across to a different line, which will be the red one. So notice I'm going up and down to change the first value, and left and right to change the second value for the intersection. We're going to store that one. And one more to go. We don't want the red one this time, so arrow down. The black one will do us. To the side, there you go, that will do. Store that. And so there's that all done. And we could have wrote them down off there into this section, but the nice thing is that if we now go into stat and then to edit, there they all are. 50-50 was one of them, 90-10, 20-60, and 20-10 for the x values, which we know links with a and the y values. Now the objective function I've already put in, but if I then want to then work at the maximum profit, well, it's quite nice for the students to see all the values. So what we can do is we can come over and add our own column. We've got to give it a name. So why don't we call it P for profit. That's there. And now we're going to put a formula up in there, just like an Excel spreadsheet. And the formula will be, as we can see from the objective function, 10 lots of the inequalities of x. Now how do I get that? Well, we go into list, and there it is, number 7, plus 40 lots of the inequality of y. And if I press enter, there we go, it gives us all the answers, and from that the students can quite easily see that the maximum profit was 2,600, and it was produced by 20A, because I know that A is linked to X, and 60Y, which is parts of B. So obviously with those answers, sometimes they either want the quantities that gave the maximum profit, or actually what the maximum profit is. Is there anything else you'd like to add to that, Carol?
No, that looks pretty good. I think it's an excellent application, that one, and I don't think a lot of people would actually know how to use it.
Yeah, very much so. And it is really easy to use. Once the students get it, and you've showed it to them once, they do just fly with it. And with that store functionality, it makes life a lot easier.
Mm.
So I'll pass back to you for your second part, Carol, and then I'll finish off with TVM Solver at the end, which obviously is linked to mathematical applications.
Okay.
That's great, John. So it's very powerful, that application, isn't it, John, seeing the graphical approach there and showing the intersection of the equations and storing all the points. It's a very powerful calculator.
It is just great. And with the colour now as well, just adds that extra dimension. Like I said, it works fine on the 84 Plus, but just adds a bit more polish with the CE, which, as I said, teachers can get those upgrades to use in their class for free.
Excellent.
Okay, Carol, all over to you now.
Thank you. Now, am I on, Rodney, or not?
You
I can
are,
see
yes,
that
you are.
low.
Moving into methods.
Yep, moving into methods is right. So we're there?
Mm-hmm.
All right. So in the methods paper from last year, there was a question number 12, which looked awful for the students. Number 12, it is on there. In a laboratory, the weight of a culture is given by a fairly unpleasant-looking little formula for the students. And in actual fact, about 7 marks out of the 11 that are there can be gained very easily with the graphic calculator. And if you understood the interpretation that you're asked for in E Part 3 then and D Part 2, you can actually get 3 or 4 more marks. So, I mean, it does make sense to use the calculator. Now, I've already stored that in there. Y1 is 100 e to the 0.04 log 2 times by x. And I've done the window, hopefully, so the graph itself is going to look just like that. Now, that doesn't show me anything much. And in fact, this is one question where most of the answers can actually be done on your home screen, because although it's called M, the function I'm calling it is Y1, so Y1 is the same as M. And it's really interesting the way students have adapted very happily to use Y's and X's in their calculator when they might be M's and T's or some other variables in the function they're dealing with. That used to create a lot of trouble, but I think that one has changed. So I've got the function in at Y1, so I'm now going to go to the home screen, clear that bit of information. Now, the initial weight is really... Decline that one. Oh dear. M0 is what we're looking for, so I'm going to find Y1 and evaluate that at the value of 0. And of course the value is 100. So we would have known that anyway, but that's just checking that Y1 at 0 is 100. So the initial weight, M0, is 100. How many milligrams would the culture weigh after 50? Well, okay, let's go up and grab that one again, and let's make it now 50. So after 50, there are 400 milligrams of the culture, which is easy enough. How many minutes would it take for the culture to double its initial weight? So this time I'll go back to the graph, and the way I would do this anyway is put in a second line in this spot. If the original weight is 100, the double weight is 200, so I'm going to graph that, and all I need to do is calculate the intersection, number 5. Graph 1, graph 2, away we go. And it intersects at 25,200. So it will take 25 minutes for the culture to double its initial weight, which is pretty easy. Go back to the home screen again, and this time I want to calculate M60 minus M30 over 30. So I don't often use this one, but I'm going to put a fraction button in this time. Fraction bar, so I'm going to put Y1 at 60. In fact, easily go up and grab this guy, bring him down, and go back and change that 5 to a 6. Scroll out a little bit further. Whoops, that's not working. That's going to be a 60. Close the bracket. Take away Y1 at 30. So go up and grab this guy again, but change the 5 again to a 3, so that's going to be 30 again, and come down and divide by 30 and enter. And so the value of M60 minus M30 over 30 is 9.93. Now, one would hope that the students would know that that's doing a slope, Y2 minus Y1 over X2 minus X1, 60 minus 30. So it will be the average rate of change of the function over that period of time. Now, the only bit that the students really need to do algebraically is E part 1, differentiate that function, and then calculate m-50. Now, they'll know that m-50 is the derivative at 50, so they ought to be able to interpret it as well for the 2 marks there. But how are they going to do m-50 if they don't know mt and how to differentiate it? So if we go back to here, you'll notice that I've got the second derivative in there ready to roll. So if I turn it on now, I've got y2 available, and that's the derivative of y1. So I don't need to graph it or anything else. I'm just going to actually calculate y2 evaluated at 50. And there we go. So that's the instantaneous rate of change at t equals 50, and the other one was an average rate of change across a range of minutes. So that's very easy. So the blood alcohol concentration, number 14, is another nice question where you can get 7 of 12 marks out of that just using your calculator. And if you know what a surge model is, which this one is, you'll actually be able to do that. Now, I've got it stored as GDB50, so I'm just going to find that one for the moment. Across the door. Recall GDB5 at least. 5, enter. And so I now should have that function sitting in there as well. 4.17 x e to the minus point, blah, blah, blah. And again, I've got the derivative in there because later on in the question we need to do that. So on a set of axes like those following, graph the function. Now, as we said already, it actually is surprising how many students do not actually look at this and put these scales into their window. So I've already done that, and so it ought to just graph quite nicely for me. There we go, a beautiful surge function. So there's 3 marks there by being able to copy that graph reasonably accurately. Probably it would make sense to check a few points on it, make sure you knew how to scale it properly and label a few points. But 3 marks is pretty easy for a press of a couple of buttons. State the model, surge model. Now, C of 30, a couple of ways to do that. You can actually do it straight off the graph, do a value when x is 30 and enter that. Or similarly, you could go back to the home screen and do y1 of 30. Interpret your answer to part C, part 1. Well, again, that's the rate of, that's the concentration at t equals 30. But let's move on to the next part. It's illegal to drive with a blood alcohol concentration of more than 50. I've never actually seen milligram % before, so I've never seen that as a unit in many, many years of teaching. So I don't know where they've pulled that from, but anyway, we just quote that, mg%, between which times after rapidly consuming 2 standard alcoholic drinks is it illegal for the young adult to drive. Well, they've got to be more than 50, so back to here. And I'm going to put in 50. Enter that and graph that. And so if I now find the 2 intersection points here and here, they're the 2 times between which the person should not drive the car because they'll have more than 50 milligrams percentage in their bloodstream. Okay, now that's another 2 marks. So what have we got there so far? If I scroll back, I've got 3, 4, 5, 6, 7 marks so far. Another 2, that's 9. Now, show clearly that the derivative is that same sort of idea as before. 3 marks for that. Well, if you can't do that, hence or otherwise find the time when the maximum concentration occurs. Well, that's going to be exactly at the top. Second, calculate the maximum value. Come on, maximum number 4. And this is something else a lot of people don't do. They don't put in their left and right bounds very well. I think it makes sense to just put some numbers in. And why was that not a good guess? Now, that's something that students do as well. And one needs to know roughly where the maximum turning point is. So I'll do that again. Second, calculate maximum number 4.
As you're doing that, Carol, it's very good in class to do things like that and get the students to problem solve and think about some of them may panic when they go, oh, I can't find my maximum.
Yeah. So if I go to 50, well, it's only just past the maximum now because I'd forgotten which one it was. So the maximum is at 43.6 when the Y value is 66.9. I think that's good practice for them, and I may have missed that there, I don't know, but round about there. But the calculator gives that to you, so that's another mark. So even if they couldn't do that derivative properly, they may well have done bits of it. They may know how to differentiate e to the x, but forget to carry over the extra bits on the side. They might pick up 1 or 2 marks. So absolutely discerning use of the calculator there, I think, gives you many, many marks that you may not have got otherwise. So you don't have to be particularly good mathematically to be able to pick up quite a lot of marks. And the other thing I wanted to talk about very quickly was question 6. There was a comment saying that many students do not understand the meaning of the confidence interval. In particular, students struggle to understand that a sample mean can be used to calculate the range in which the true mean actually lies. Now, I wanted to comment about that because this is the examiner's comments, and the examiner is actually incorrect there, because the true mean does not necessarily actually lie within that confidence interval. And I think students need to know that. It's very important. It does not actually necessarily lie there. So there was a question here that said, peach growers concerned that his peaches are underweight. So we've got a mean X bar of 145 from his sample of 120 peaches. Now, it's interesting also, this may be peculiar to maths methods, but they say the standard deviation of the population is 25 grams. Now, that's what that sigma equals 25 is actually saying. Now, I would have thought that sigma was not actually known, so that if you teach the methods course next year, or you teach studies at the moment, the students need to understand that it's actually more likely that you would be using the standard deviation S from your sample of 120 peaches there. But anyway, calculate the 95% confidence interval for the population mean, interpret the meaning of this interval, and state the width. Now, they're all pretty easy things to do, but the interpretation is the thing that's important. It's very easy to do on the calculator. I won't do time with that at the moment because people will know how to do that. But a 95% confidence interval does not mean that for a given interval, calculated from sample data, there's a 95% probability the parameter lies within the interval, nor that there's a 95% probability that the interval covers the population parameter. Now, in actual fact, that is an odd statement, and I got that from a text. But the important point about this is that once an experiment is done and an interval is calculated, the interval either contains the parameter value, the proper mean, or it doesn't. It's no longer a matter of probability. So it's something that has to be carefully rehearsed, I think, for the students. And the 95% probability relates to the reliability of the estimation, not to a specific calculated interval. So I'll just push through this. If people are interested, they can have a little look at that a bit later. Having found a confidence interval, which is between 141 and 149, 95% of the time, that confidence interval will contain the true mean. Now, it doesn't mean that it necessarily is in there. And I've just put a bit of stuff on paper, and I will send with the PowerPoint that goes with this another couple of sheets that relate to this idea of confidence interval. But I think it's really important that people understand where the confidence interval comes from. And they know about the bell curve. That's something that was talked about specifically in the examiner's comments. They also understand that about 95% of that population is within about 2 standard deviations of the actual mean. So that when you know that the X bar, the mean, is from a population with exactly the same mean, from a sample at least, from a population of means for which the mean is the same as the population itself, but with a standard deviation that's reduced by a factor of the square root of n. So in actual fact, X is going to belong in a group like that, and the probability that it belongs in there is actually 0.95. Now, I think that's got a square root of n left out of that. So looking at this last point, in actual fact, if I wrote that properly, this would have a sigma over square root of n, that would have a sigma over square root of n there. The important thing is that the probability that your sample mean lies within that range is 95%. And the confidence interval is found by rearranging that. So x bar, no, I've got that around the wrong way. Any point x belongs within there with 95% out of the population. When you do a sample, the central limit theorem tells us that the sample belongs in a population with the same mean but with a standard deviation of sigma on root n. And so we can say that the probability of that happening is 0.95 as well. And that inequality statement is rewritten, making mu, the mean, the subject of it, if you like, in the middle, and this is how the confidence interval is actually derived. But it comes out of the knowledge that the x bar comes from the sample of means, population, and you can get a confidence interval following these little procedures. But, and the other thing that's really important is that I think we generally use a 95% confidence interval, but they can be 90%, they can be 99, and all that does is change the 1.96 to something different according to the Z value that would actually change it. So the last thing I wanted to say in terms of methods and applications, answers generally should be given to 3 significant figures. I think it's the case in specialists and in studies as well. The only time that would be different is if you're calculating a number or a specific number that you needed for a sample or something like that, where you might round up to a whole number or something less than that. But otherwise, give answers to 3 significant figures as you go. So, back to you, John, please.
Thanks, Carol. That was great.
So we'll hand over to John.
There we go. Okay, so to finish off with, I'm going to look at TIM Solver. And you'll know that there are many apps that are already available on your TI-84. You can download some more, the extra ones that maybe you want to use with your students from the TI website. And these are all available here, free for you to download using TI Connect to connect it to yours. But yet, TVM Solver is probably the main one that is used by students, and definitely the main one that would be used by the app students. So what Carol and I were both talking about was the Chief Examiner's reports from the past exams. This is the SACE website, and if we go to Maths Applications, oh, my internet's all of a sudden gone very slow. How about that? There we go. We can see that in here we have the Chief Assessor's reports and the past papers, and that's what we are using with some of our notes tonight. And this one here is taken from the last 3 years from Maths Apps in the the Savings and Loans section, which links with finance, obviously, and it talks. Each time it talks about how students get confused when they're using these apps on their calculators. So here we go into apps, into finance, that they have confusion with the negative values. And therefore, I think the easiest thing that you can say to your students is, if it's money coming out of your pocket, then it's negative. If not, then it's positive. So money out of my pocket is a negative. Everything else is positive.
It's a good way of saying, John, with the money coming into the pocket of positive, feel very happy about that, don't you?
You certainly do, and I certainly feel a bit more negative when I give money to the bank for my mortgage. I was quite happy to get the money in the first place to get the house, but now I'm not so happy. But there you go. So actually links quite nicely with that, Rodney. I just missed something out there that I just wanted to show you that is easily rushed through, and I did exactly the same, is in the finance. We're going to go straight to the TVM Solver, but there's lots of other functions down through this column that we can actually access. One of them is the effective and nominal interest rate comparisons, and there's some information there on those two. Those are here, which you can use. We'll be talking, hopefully if I have time, about these ones here, which we can actually work out the sum of the interest or the sum of the principal. And also, like in statistics, we have the variables, which we can actually access all of these either from inside the app or inside in the actual normal calculator screen. The variables are still there. So that's quite overlooked sometimes, and I think that has some merit that should be used as well. So here we go. So this is probably the most important thing, that students know what each of these pages are. And with students being allowed, still currently at the moment anyway, a cheat sheet, for want of a better word, then having information like this written down by the side of all those helps them. They should know what they are. Notice that the interest rate is an interest rate, not as a decimal. I try and encourage my students to know that the number of payments is the payments per year times the number of years, and get them to do this as a calculation in that section. And the other ones that people should be aware of, but maybe just helps elaborate for their students what they actually are. I also encourage every time my students do a new question to link it back to zeros again, zeros and ones, so they know which ones they've changed, or equally on their answer sheet to write down all of those variables, N, I%, PV, etc., and then write next to them on their piece of paper. Now, that doesn't count as marks because the examiners won't mark to calculator speak, but it will help the students know which ones they've got to fill in and which one is the alpha solve. So, another thing that is quite nice is to set the calculator up so it is money to actually be in the format of money. So we can go into mode, and we can change it from being a float to, oops, went too far down there, to 2 decimal places, and that will give all our answers to 2 decimal places now, rather than just lots of decimal places afterwards. So it will actually help our students with their numbers and their calculations much easier. And you can see now that it's changed. Looks a bit weird for some of them, for the ends, for example, but it'll actually help on the money one. I quite like that, but again, give the students the option and let them decide. So most of these questions from the 2015 paper, I'm going to show just on the calculator and show you how we can answer most of them this way. So this is the first question, was a sinking fund. It says that we want to borrow 280,000, and we're going to have so we're going to borrow it, so we're going to get it. So 28012, there we go. That's that. The interest rate is 6.2%. It's payable half yearly, and notice that when we come down to the payments, that both this one and the compound will change together. I don't think I've ever seen a question where these are different, but just be mindful to students that they could be. And how long are we going to have it for? Share for 2 years. Okay, so we need to come up to here. So 2 years times the P/Y, twice per year, which obviously we should know is 4, but just quite nice just to get the students in the habit of working it out. And obviously in the future, it will still be the same because it's a sinking fund. Nothing's actually changing with this one, and we therefore can use it like this. Now, obviously you don't have to do it in this app, but if you're encouraging them with the students to do it for other things, then maybe it's quite nice to do it in here. And we go quickly at alpha solve, and there is the answer. Now, what have I done? Mobile interest at flat rate, 6.2% payable half yearly. I feel this answer is wrong here.
John, I think you might need to actually change it to money coming in, money coming out, etc., the negative and positive. Would that be the case here? So you've received the money and 280,000. So
no, it's going to be. This should work out correct. I was all confident with this one a second ago. There we go. Thank you, Rodney. Of course, because I've got to pay the money back to the bank. Mm-hmm. You're right. Thank you, Rodney. I'm glad you're on the ball there, mate.
That feeling again, money going out.
That's it. So you were paying attention to my teaching. I just wasn't. I was just miles away from it. All right? So thanks for that, Rodney. So yeah, of course I've got to pay it back to the bank here, and therefore that's why it wasn't working out correctly. So we can use it for that. Okay, now the sinking fund earns 4.5%. So again, what I said, if we're going to start a new question with the students, encourage them to turn them all back to zeros.
It's a very good hint, that one, John, actually. Sometimes they do get confused leaving a figure in a previous question and they can't work out why.
Yeah, exactly. Thanks, Rodney. And also when they go through it now, they can then see. I still like them to write it on a piece of paper, to be honest, because I think that the blanks are even more effective. And when they're reading through the question, they can see it a bit more. They can literally filter it as they go along. So it's compounded monthly, and they're going to monthly deposit, and we need to make, in order to save, 2,800 in that time. So we need to have that money available, okay, in that time. So this time will be, I want to have that money available for me in that time. I'm not paying it back to the bank this time. It's going to be money for me. Again, on the N, we're going to go for 2 years and times the 12. So again, keeping every question consistent in what I'm asking the students to do. And here we go again, alpha solve. And there is the answer. So I need to pay to the bank, which is negative 11,171 every month. Whew, blimey. Can you afford that, Rodney?
No. We're teachers, aren't we? We can't afford that.
No, I think I'd struggle with that. Okay, calculate the total cost.
$280,000 in 2 years at all. They learn.
I wouldn't mind that job. Now, notice we can still do calculations on the end of these as well. So if I want to calculate the total interest only loan of the sinking fund, then we know that we need to times that by 24, because that's how much we're going to get, all those payments are going to be. And I equally can go to the end, and I need to also include, obviously, the 4 payments of from Part A of the 8,000. Obviously, students got to be a little bit careful doing it this way with the negative. As I said to you, and I will just show you that we can come out of that if students don't like to do it in there. They don't have to remember that number. Remember that I showed you that we can come across into the vars, and there's that PMT here. That will be that number that I now wanted. We can go negative that number if we want to, or we can, many different ways of encouraging the students to do this one. We can left it all as negative, it wouldn't matter too much, plus 8680 times the 4, because it was over 2 years, every 6 months, and that will be the answer for that one, 302,833. What a bargain. And I could keep on going through this sinking fund question, but looking at the time, I think I'll move on to another question. And shall we have a look at question 2? Yes, let's look at question 2. Good old Baz. So here we go. Let's help Baz with his finances. And it's been quite nice. I love teaching this topic. It's one of my favorite topics to teach, just to scare them and making them appreciate their parents a bit more about how much money their parents are paying in mortgages. But also get them to realize which car they're actually going to buy. They always tell me the car they're going to buy, and then also when they work it out, things are slightly different than they were before. Okay, Baz has taken out a loan, so he's got that money. So he's got that money already. Doesn't feel like you actually get it, but it seems to just disappear, but you do actually get it. In order to buy his first home, the interest rate at the moment is 5.2%. And it's compounded monthly. So here we go. I know I should change the second one, but I'm just going to stick it with there because it will be for the loan for the 30 years. It's 30 years. So again, to not confuse the students, they're simply just going to go 30 times the 12 because that's the payments per year. I pressed 12? No, I didn't. There we go. And we can now look through those numbers. We've still got 2 numbers here that have to be adjusted. We can see those blanks there. Well, obviously, if it's a loan, a mortgage, and hopefully at the end of that time, if we haven't, if we've been working hard like Rodney, we should have no money that we still owe. And again, we now go alpha solve. It should be a negative because we should be paying money to the bank each time, and it is $988 £1.40. So Baz can afford to repay $1,200 per month. Good on Baz. Show that they'll take bags approximately 20 years. Now, I like these show that questions. Some students don't know why they're there. Obviously, you want to encourage the students to know that if there's a show that question, then you will need this answer in the second part, and the examiners don't want to ping you twice for marks. Rather than it being worth hitting you for 4 marks, it's just separately. So that's why it's a show that question. So please encourage your students that if they can't do part 1, they still can do part 2 because they can use this answer they got to show that. But also that means they can't just write down 20 as their answer. They're going to have to write down the exact number and then show that it's close to the 20 years. So we now need to increase that. That is going to increase it to 1,200. Everything else, all the loan conditions, everything else stays the same. We come up to here, alpha solve on the time, and we get 242. That seems a bit strange, but no, oh, well, that's right, because we're in months. So if we now do the opposite of the times by the p/y, we do divide, we'll find out how many years it is. So it's 20.23, which is what the students would write down, and then they would say it's approximately 20 years. So when they do part 2, they can either use the 20.23 or they can use the total. The total interest that will pay if his loan is approximately 20 years. So you could do that in here, and I could show you that, but I'm going to show you a different way to do the same question. And we can actually do it in one of these rows, but for clarity, I'll take us out of this. And what we can do is use one of these other functions on here, and that is the sum of the interest. And the syntax for the sum of the interest you need to know, and you basically can find the sum of the interest between any 2 time periods that you want. So between, say, the first month and the second month, or between, say, the 13 months, the second year, and the 24th month. You can find it wherever you want. So we know that it's between 1, we want it from the start to the 20th year, but it's in months, so we want it to the 20th year. Have you used this before, Carol?
No, I haven't. I didn't know it could do this.
Yes, there you are, look.
It's a hidden gem, isn't it, John? It's a very hidden gem.
It is a hidden gem, my friend. And there you go. There's the answer. 111,321 that I would have to pay in interest because I'm paying it. It's negative to the bank. Now, like I said, I can actually do that in the app. I don't have to do it out of it. So the students could just choose anywhere they wanted to put it and do the same calculation in this row. It would work out exactly the same. Now, I'm conscious of the time, Rodney, and there was...
Go with it, John, because we did start late due to the internet issues that I was having personally.
Yeah.
You may as well go because we did start at about 5 or 6 past 7 tonight. So it's probably best to give people a question and techniques that you and Carol show.
Yeah, okay. All right. So
John, what is the end and beginning thing against PMT? Right at the bottom there.
Yeah, and I put that on the earlier slides. So what that means is when the payment is due. So majority of the questions, and I think every question I've seen in the SACE or NCCT exam has been for the end. But it would be where you were paying money back on something and you paid it back. You paid something at the very start of that month rather than at the end of the month.
Right. Okay.
So pretty much, and I've seen the odd question in the textbooks that revolve around that. Majority of the time, it's always at the end. But it is worth just telling the students about that. Mm-hmm. But yeah, I think that we could go through some other questions. I think that really the main thing that you're trying to encourage the students so that they don't make the errors that are coming up in the Chief Examiner's report. Is, like I said, with the end, to get the students to think of it as years times the payments per year. That if it's a negative, then it's the money that you're paying to the bank, or like that sinking fund that Rodney corrected me on, you're paying the sinking fund money back to the bank, and that you can actually do calculations within the app. You don't have to come out of it, and the added features that are also in it for both the CE or the 84 plus, both in the calculate and also the variables that you got available to you as well.
Go back to that one again for a second, would you, John? Just go back to that. Go to VARs and...
Oh, you want to go across to that? So let me just explain something. If I just explain something well, I'll come back to that, Carol, one sec. This question that we were doing, this question here with good old Baz, how long was it for? Monthly repayments for 20 years. So, of course it was. Oh, no, it was 30 originally, wasn't it? 30 years. So if we go here, and then, Carol, this may come into what you're actually going to ask, or it will link across. We have borrowed that, and we had our alpha solve here. We sometimes have questions where it says, how much do you owe after a certain period of time? There is a question in the 2015 paper where it changes. So I think after 10 years it changes. So we'll come back up here and change it to 10 years times the 12. So this is quite common. And then something happens. So we now know that that's after 10 years, 120 months. We still owe money to the bank, and that's how much money we now still owe to the bank. But that's our money. Then normally the question says that we now pay some extra money back, or we go on holiday and we owe more, an extra 10 grand or something. So that number then needs to get transferred up to the principal value. And there's two ways of doing that. Obviously, students can just simply go up here and clear that and type those numbers in. That's one way of doing it. But the other way, if they want to, I don't know whether it's lazier or more efficient, I'm not sure which is the right word, but we can actually go back into here. And Carol, is this where you wanted to get to?
Yeah, so you just scrolled up, but yeah, keep going though, John, at the moment. Yeah, just keep going.
If we go to future value, we can we can actually dump our future value back into our principal value. So don't forget, that's only a value, it's just a variable. That now then comes up into here. So then we would then get rid of this value on the end. Now, I don't know, I quite like doing it that way because I like to see that value getting transferred across. So if, for example, I don't know, the person got a bonus, they can pay off some more money quickly. Also, I wouldn't use that negative. I'd use a takeaway. Let's say they got an extra 20 grand. So they paid that off their loan. They now owe that to the bank, and they then say, well, okay, the interest rate stays the same. But how much quicker will you be able to pay it off? It was going to be 240 because don't forget that was 10 years on and it was a 30 years. So if we now go alpha solve on here, we can now see that it's been reduced down. And if we want to, it's a bit, oh no, I'll do this way, I'll stick to the start, go second insert. It was going to be 240. So if we do our 240 and take away the 188, we've actually saved ourselves 51.15 months, which we come to the end and divide by 12. Is actually going to save us 4.26 years. And I think that actually covers one of the later questions, Rodney, anyway. I think that was question 3, I think it was.
I think it was number 3, yes.
I could be wrong on that, but it's one of the later questions. But yeah, actually manipulating stuff around, most of the finance questions can be done in this screen. The important thing is students understand what the variables mean and then how to use them. So I think that is me done, unless Carol likes to add anything else to that.
No, that's fine. I think that you could spend a full hour on using that TVM solver, actually, John. You know, it would be valuable for TI, I think, to have a full webinar on that, showing all the intricacies of it. What I was going to ask you, in some of the other functions, I know that when you go back and find it, so would you go back to that VARs thing for a minute? So go back to your application for a tick. And now go over to variables, and you wanted some syntax for something? No, sorry, go back to calculate and then scroll down, or up, yeah. Now, if you go up to A, just scroll upwards. Now, if you press second plus, I'm just wondering if that brings up your syntax for us.
No, it doesn't, because
It doesn't, right?
No,
Yeah.
that doesn't. And with the new operating system, it naturally will tell you if there's something. If it'll tell you the syntax, it will naturally do it for you. If it won't, if it doesn't have it,
For you. That's right. On the CE, it does that. On the others, it didn't, of course.
yeah, that's
No,
right. And no, even the 84 Plus now with the new operating system,
the new one.
which again, all these operating systems. It's funny. Our students update their phones, and admittedly they get a message on their phones to say you've got a new operating system. They'll update their operating systems, the same day you get the message. A lot of their calculators are running on the old one, so we can see here that the current operating system of the 84 Plus is 2.55, and the current operating system for the CE we can then find is, here we go, CE is 5.2. So I've got a slightly different version on this one, so I'll just change my calculator screen to the 84 Plus. And because I can go to full screen, because I'm not now using all the other stuff. Just make that a bit bigger. And it's really nice, this smart view is really nice how we can change things around and how we can view it differently. Don't forget to find out what operating system you've got. Go to second mem. I want to find what it's about. And there we go, it's the 2.55. So very interesting to see with your students whether they actually are running that. And I was thinking, Carol, with yours as well, with some of that stuff where you're showing the graphs, again with the smart view, it's quite nice to have the views of the other calculators down by the sliders, and it's quite nice with the smart view to have that running on. But obviously for you it wasn't possible because you had the PowerPoint going down the side. But for a teacher in the classroom,
absolutely.
Nice for them to have.
All right there, John.
Right, and I'm done, Rodney. Thank you very much. Thank you, everybody, for listening to me tonight. I hope you found some of that useful.
And the same for me. Thank you very much.
So just wrapping up, so Carol and John, thank you for a wonderful webinar, and I'm just about to share my screen. And I'm just wrapping up tonight regarding the future webinars. There's a whole lot that John and Carol showed you on the website regarding the downloads and all the information the teachers, but for future webinars, so the Texas Instruments Australia website, and you click into the tab and you have the upcoming webinars. Obviously, here we are tomorrow night. They're back again with the same crew, and we are looking at the mathematical studies and specialist mathematics and the future webinars there as well. And if you've missed any webinars in the past, and obviously tonight's webinar, in a day or two, you will actually see the webinar that has been recorded, uploaded there, and the various documents that Carol and John have actually demonstrated. They'll be there, and there's so many here you can do. So thank you very much for a wonderful webinar to both of you. So good night, John.
Good night, Rodney. Thank you all. Thank you, Carol.
Thank
Good
you,
night,
Carol.
both of you.
And thank you for viewing, and we look forward to your participation in future webinars. Bye for now.